Tonight, look up. Find one star, just one. Now consider this. That star probably has planets. Some of those planets are probably rocky, like Earth. Statistically, a fraction of them should have liquid water, stable sunlight, and billions of years of quiet chemistry to work with. So, where is everybody? That question sounds like a joke you'd hear at a party. It isn't. It's one of the most serious open problems in modern science, and nobody has solved it. In 1950, a physicist named Enrico Fermi was eating lunch with colleagues at Los Alamos. They were joking about UFOs. Fermi did some quick mental math, the kind physicists do instead of small talk, and landed on a simple, devastating line. If the galaxy is old enough and big enough, then intelligent life should already be everywhere. So why isn't it? That question now has a name: the Fermi Paradox. Here's why it should bother you more than it probably does. The Milky Way is roughly 13 billion years old. Earth is only 4.5 billion years old. That means there was room for civilizations to rise, build starships, and spread across the galaxy for over 8 billion years before humans even showed up. Even at slow speeds, a civilization with basic self-replicating probes could colonize the entire galaxy in a few million years. That's a blink, cosmically speaking. So if it's that easy, and there's been that much time, the galaxy should be loud. It should be humming with signals, structures, maybe even visible engineering on a stellar scale. Instead, you get silence, total, undisturbed silence. In 1961, an astronomer named Frank Drake tried to put a number on the odds. He built an equation, now called the Drake equation, that multiplies together the number of stars, the fraction with planets, the fraction of those that could support life, and so on, down to the odds that a civilization would want to communicate at all. Plug in optimistic numbers, and you get a galaxy that should contain thousands of communicating civilizations. Plug in pessimistic numbers and you get one. The gap between those two answers is enormous, and that gap is where all the actual anxiety lives. Here's the part that gets strange. Most people assume the silence means we're early. Maybe life is rare and we just happen to be one of the first. That's comforting. It's also probably wrong. In 1996, an economist and physicist named Robin Hanson proposed something colder. He called it the Great Filter. The idea is simple and a little brutal. Somewhere between dead rock and galaxy-spanning civilization, there's a filter, a step so difficult that almost nothing gets through it. The unsettling question isn't whether the filter exists, it's whether it's behind us or still ahead. If the filter is behind us, that's good news. Maybe it was the jump from simple cells to complex cells, a transition that took Earth almost 2 billion years and only happened once. If that's the hard part, you already survived it. Congratulations, you're one of the rare success stories. But if the filter is ahead of us, that's the version nobody wants to think about. That would mean every civilization that reaches roughly where humanity is right now, curious, technological, capable of sending signals into space, eventually hits something that wipes it out. Every single time. No exceptions. What could do that? Nuclear war, engineered pandemics, runaway artificial intelligence, climate collapse, or something nobody has thought of yet because the civilizations that discovered it didn't survive long enough to warn anyone. Feel that for a second. Every quiet night sky isn't just empty. It might be a graveyard with the lights turned off. There's another possibility, and it's almost worse in a different way. Maybe the aliens are out there, doing exactly what a rational species would do, staying quiet. If you knew that broadcasting your location into an unknown galaxy might attract something far more advanced and far less friendly, would you announce yourself, or would you go dark and wait? This idea even shows up in real proposals. Some scientists have argued that METI actively transmitting messages toward other stars might be one of the most reckless things humanity has ever done. Not because aliens definitely want to hurt us, because we genuinely have no idea what's listening and no way to take the message back once it's sent. So here you are on a rock in the suburbs of an ordinary galaxy, sending signals out anyway. Reality TV, radio broadcasts, radar pings, decades of noise drifting outward in every direction, whether anyone intended to say hello or not. Now here's the twist that should actually keep you up at night. This entire problem isn't really about aliens at all. It's about you. The Fermi Paradox isn't just a question about the galaxy, it's a mirror. It forces you to ask what kind of species humanity is going to turn out to be. Are you early in the story, still climbing towards something bigger? Or are you approaching a wall that every other curious species in the galaxy has quietly hit and never mentioned because there was no one left to mention it? You check your phone dozens of times a day, scrolling past notifications, emails, group chats, none of it screaming into the void, all of it staying safely local. Meanwhile, above your roof, the galaxy sits in total silence, holding either the best news imaginable or the worst. Maybe that silence isn't proof that you're alone. Maybe it's a test nobody told you was already running, with the results still years away. So tonight, look up again. Find that same star. It's not empty up there. It's waiting. And so, whether anyone planned it this way or not, are you?